Butanone can be formed via a three-step synthesis from compound E. Give the full IUPAC name of compound E. So we've got 1, 2, 3, 4 carbons, which means it is going to be bute. Now carbon 2 to 3, so that's 2-ene. And remember, if you're asked to name something and it seems too simple, it usually is. So the priority groups are on the same side, so it is Z-bute-2-ene. Part B, give the name and the mechanism for reaction 1, the conversion of compound E to F. So this one is electrophilic addition. And then part C, give the reagents and conditions needed for reaction 2. That is converting F into G, so that's a halogenoalkane to an alcohol. So that's the substitution reaction with hydroxide, and so the reagent then will be either sodium or potassium hydroxide. The conditions here is it needs to be aqueous. That's an absolute must, because if it's ethanolic, you get the elimination reaction instead. And you might see on the mark scheme that it says warm, but in light of recent papers, you need a high temperature. So you need to say high temperature there. Okay. D, if the conditions for reaction 2 are altered, another organic compound can form. Give the skeletal formula of the other organic compounds. This is the one that I was on about. Okay, so if I remove this from here, okay, so this is with ethanolic conditions, it will remove it with either a hydrogen from here to form a double bond there, or it will remove this hydrogen here, which will form the double bond here. Now, with 1, 2, 3, 4 carbons, it means it's either going to be bute-1-ene or bute-2-ene. Doesn't really matter, but I have to draw it skeletally. Key thing is here, so 1, 2, 3, 4. So the double bond can be there, or 1, 2, 3, 4. And the double bond can be here. Either of those is absolutely fine. Butanone is formed when compound G is reacted with acidified potassium dichromate. Give the conditions for this reaction. So, well, let's finish the question. And an equation for the conversion. You should use O to represent the acidified potassium dichromate. Okay, so butanone, that's a ketone. It can't oxidize any further anyway. So we would reflux this one. Remember, the only one that we distill is the aldehyde. So that is that. Now compound G is butan-2-ol. So let's start with that. So CH3, CHOH, CH2, CH3 plus O in square brackets is going to give me CH3. Now, it doesn't matter if I display a little bit here, but this will certainly make it easier to see what's going on, which gives me that, and then I need water on the end of it there. So there's 1 mark for reflux, 1 mark for the balanced chemical equation. Part F, butanone can react with KCN followed by dilute acid to form compound H. Name and outline the mechanism for this reaction. So let's do the mechanism first. So CH3, CO, CH2, CH3. So KCN, so I need my minus charge on the carbon. Lone pair of electrons there. So curly arrow from here to here, and then a curly arrow from there to there. That's going to give me my intermediate. There's my minus charge, CH2, CH3. My cyanide is down here. Watch out for connectivity. Make sure it's going to that carbon. And then the clue here is followed by dilute acid. This is where a lot of people get it wrong. So they'll put water in where the clue is in the conditions, which is why it's important to learn these. So the curly arrow then is going from the lone pair on the oxygen to the hydrogen ion here. And that gives us our final product. And this is a nucleophilic addition reaction. So there's 1 mark. Let's do the marks. 1 mark for nucleophilic addition, 1 mark for that curly arrow, 1 mark for that curly arrow, 1 mark for a correctly drawn intermediate, and 1 mark for the final curly arrow there. Okay, and then G, compound H exists as stereoisomerism. Define the term stereoisomers and state the type of stereoisomerism shown by compound H. So compound H then, so this is optical isomerism, because I have 1, 2, and then the OH that will go there, 3, 4 different groups. Or if I go back to, where are we? Oh no, it's not in the profile, that doesn't matter. And then the definition of that then is that it has the same structural formula with a different arrangement of atoms in space. So 2 marks, 1 for the definition, 1 for the type of optical isomerism.